Hello, I am sure so far what we have come, you have probably able to start a little on how to do this simple 3D printing. As I have showed you before and as in the video that you have seen already, the whole thing is how to create a proper solid model. Have solid model we print, and there is this issue about how to orient the model while you are building up. Now, another equally important thing when it comes to CAD is if you take any practical objects, even if you have G codes and if you do it by 3D machining, CNC machining, you start with a solid model, and main advantage of any of these working on these things seems to be you can manipulate the object and store it as you like for as long as you like. So, I will start with a small example so that you will appreciate I need not stress it again and again. Anyway, you know by now you know how well things are and all that. Imagine I just wanted to create a small, how do you say, a device here. You just have a look at it. I am sure you will enjoy it. I am sure you now have an idea of what this device could be. It is nothing, it is just an intersection of two cones, and I have made an object, and then just for good effect what I will do is explode it, remove one of the end caps. So, what do I have here? I have what looks a little like a funnel. Advantage for me is all the geometric dimensions are all available for me for whatever I want. Main thing seems to be in that whenever we want to now, if I need to duplicate it, one of the simple ways to copy it. Now comes the much more important or much more interesting object. See here, I have a funnel with a given what you call shape, the hopper part which collects, and then the other feeder part in the bottom, which I can do whatever I want. Depending on my requirement and these things, I can now what you call improve on it by manipulating the dimensions. If you see here, I have one surface here, I have another surface here, yeah, and if I now turn on the points for that and I turn on the points for this, it is possible for me now to play around and make it of any shape I like here. Can you see here? Bottom, this part, I have this surface points. So, I can scale it up, I can make a simple scale 2D. See, this part has become a little bigger now. Now, I can just drag it here, attach it I can make an object which now looks different and probably it is useful. So, one of the important things what we do is, in general, if you see all these objects, now I thought I will show you here, I will start with my samples here. Sir, please show this thing. Can you please show me the main camera? You see here, this is a funnel, a little like what I wanted to create it there. This is a normal standard funnel, and then if you see here now, some of them come with capacities, some of them no come with just numbers, and then you have all these features. I have something here. Now let us say, after working a little, I have found out this is not just enough for me, I need something else. Now it is a matter of scaling, and I can make something almost similar to the other one, except that it is quite, you have seen it, quite small. In fact, if I want, I can make them stackable, and here comes the actual beauty of it. I can also make it big. Main thing being, the drawing is about the same. This one was a standard thing. This is made for a technical thing. It is made to be part of a standard funnel, which is 200 mm, and it is used for a rain collection device, typically a rain gauge. So, in the case of a rain gauge, we need this, and then remaining things have been put. Now, this material is one thing, it looks fine, absolutely no problem and all, and this is where actually I am coming to the crux of the whole lecture today. Now, you have seen this. This is also a little about the same, but the material seems to be slightly different. This is shiny, no shining end. This one is a little slightly different shine, and then this has the luminosity for both these things are different. They are mildly different materials, and a little bit of detailing, it may not be visible there. If we keep it in a collecting device, chances are this has a tendency to choke up, because there is no place for collecting for the air to go out. So, there is a chance for the air to go inside and all that. Now, instead this has been made with small flutes all around here. There are small flutes here. So, when you put it in a jar or a what you call measuring jar, air escapes out and we can easily pour the material inside. The magic is, all of them, the samples can be printed by rapid prototyping, and just by a simple scaling method you can even find out what is the volume. And most 3D objects here, most 3D software here will, if you go and point out this thing, I'll just go to undo and go back to the original cone and things which I have made. So, if you see this, this is, let me say, it is part of the structure what I have made here. And if I highlight this, go here to these, analyze the properties, things like, I hope I get it properly. So, beautiful volume is also taken care of. I am not able to see properly, but it clearly says it is 2150, or let me say it is around 2000 cubic millimeters. So, if I divide it, and then I can make it into, if I divide it by 1000, it will become 2 cubic centimeters. It is a matter of scale that I can make things which are bigger and smaller. So, I will just what you call sort of abandon this here and come to a more interesting object here. Imagine, now look at this. This is the fan I have been showing you all along. This is heavy. This made with, part of it is probably made with what you call a type of aluminum, and there are two materials, and you see the thickness also varies depending on the power, the diameter, and various things. I can change the material at will as I want. Seen this, no? There is a mild difference between the two. And if you see, next is, if you see the way the blades are formed, can you see? These blades, no, have a slightly different profile compared to these blades. See this? Slightly different, and even if you see the diameter in the inside, that is dependent on the motor characteristics. Now, very important thing which I would like to, I do not know whether it is visible or not. If you see any of these fans, and if you are one of those usual hackers who goes around assembling and disassembling thing, you will see a direction of air and a direction of rotation. In this particular case, it says a rotation should be in this direction, and in that condition the air flows towards me. Why is it important? And maybe if you just run it in reverse, will it be equally efficient or not? So, we have a little issue here about it, which I will come back here. Now, using the same file, it is possible for me now to manage to make something which is thinner. You see here, much thinner, and if you see the inside, no, that thing is the impeller part. This is a heavy fan, this one is a little lighter fan, and the mounting holes are the same. All of them are based on probably a similar or a single drawing. Long ago it was not possible like this. Now come to the interesting thing, having this file, just like whatever I have done with the funnel, I can now do it with the fan. Very interesting, no? I have a fan which is a little smaller. Okay, now maybe I will take this as a reference. I have a fan, and you see here, this is even smaller than this. This seems to be a practical limit, and then actually if you open one of your computer power supplies, you will find really tiny fans. And still further, if you go down to your PC, if you see the PC cooling devices, no, are very really tiny things. The advantage of 3D printing is, at least in the first cut, you can try all these things, saying how well they work. Now, which we come to, again coming back to each fan, no, every fan has this, one direction of rotation and direction of, here also it is marked, same thing it is, here also it is marked here, air direction, if air direction is there, it is. Now, which will come to the very important things. Why is it so important? So, I will just go here and try to see what best I can do, kindly bear with me. So, what is done is usually a bit of fluid mechanics, a bit of everything is tried. So, typically this is how several of the fan blades look. So, one of the characteristics, have you noticed, the characteristic seems to be that the air as it enters comes in this direction. See this, no, air comes like this, and then finally it exits here, and this is typically depending on the complexity of the what you call of the device and so on, the direction of rotation this is how probably a cross section of the blade looks like. It looks like a what is called a cambered aerofoil. Now comes the very important thing, why is it required? Why is this very peculiar this thing is given is, when the air enters, typically it enters axially. When it leaves, because of this rotation, no, it has a tendency to also go at a slightly what you call angle. This of course I have unnecessarily made it a little drastic. Now, Just be with me very quickly, I will create a arrow. Here enters there, looks good enough, is it not? Now, when we reverse the flow, this whole characteristic is gone. By just reversing it, you are not achieving anything. In fact, it will be very, very, what do you say, impractical and not at all. Oh, I think I have written it in the reverse direction. Actually, when it enters, I am sorry, the other way it is correct. So, allow me to just rotate it to the other direction. Yeah. Air enters here, this edge, this edge tries to cut it and this comes to go here and all that. Is just, I mean, just ignore the shape and all that, the aerofoil will be in reverse. Now, if you are to rotate the thing in the other direction, often the whole purpose of it will be lost. It does not, what do you call, behave properly. So, this is where our 3D printing and trials and all easily help. It is very easy for me to create. So, if this is one of the things, I will take a detailed thing later to make a mirror image is very, very easy. This particular thing helps when the blade is rotating in this direction, and if you want it in the other direction, just reversing the polarity will not help, it will not be equally efficient. Those times they also need to create a mirror image of this. If you make a mirror image of this like this, then and also reverse the what I call rotation, then the efficiency of the wing or efficiency of the aerofoil is protected, which is very, very easy in the case of our rapid prototyping. So, you will notice that it is not just a matter of printing just for the heck of printing and so on. It is about playing with all the technical parameters. If you want to create a smaller fan, done. If you want to make a wider fan, done. And next comes the very, very important thing. Now, please have a look at this. We have so far successfully showing you only fans. This is made with transparent material. Do not ask me why transparent material is required. In this particular one, even seems to have some LED and all that. I do not know why it is required. Probably we need to look at things inside. This probably is the same file which was used for printing this. You understand, no? Transparent. Oh, I am not very sure what the material is. I will risk saying it could be a type of what you call polycarbonate or something similar, but fully dyed black. Plastic, both are plastic, both are thermoplastic, both are injection molded, transparent versus opaque, all dimensions being the same. This is where we come to my topic of today's or this lecture. I hope I make justice to it. Other than the samples, we have not been actually able to fire any jobs and give you first hand information. I cannot give you any first hand information. All the information I have here is all about which is taken from the websites. Then I have also posted a lot of links which if time permits and during the editing, I will see if I can make things. Now, if you can look at my actually the main screen which I am going to show, and maybe you can read along with me, not the PC, you show me this. You see here there are a very large number of objects out there which require various types of materials. This is a very commonplace LED tube, I mean LED bulb they call it. lot of difference and lot of what you call commonality. The parts of the country where this is being recorded, we have old bayonet type of what you call cap, and you see here this material is a heat proof opaque material. Advantage of this opaque material is it can hide all the electronics inside, and then we have a translucent material which is an opal type of material which can diffuse the light, so that it looks a little like the regular what you call bulbs and all which you see there. So, if I go to the next picture, same thing except that we have a 22 mm screw base there, and you see it is a little more, the bulb seems to be a little circular compared to the ones which you have seen here. It is not that much of a circle, it is only a half a hemisphere. So, thing of interest is we can now even color it. So, and then you see here obviously it has some other function. In this case there is a high power electronics, and it is able to by wireless and both by iOS as well as Android, you can control the color of this whole device, and we have a heat sink that is made here, and obviously they are made of very very interesting, absolutely what you call breathtaking materials. I seem to have missed the correct, this is same thing here, you see here the I have a beautiful what you call LED bulb here which is almost a round perfect globe, and when you suspend it and then from a distance it has a look which is it will spread light around, and it is really interesting to see such things. The point I am trying to make here is you have different materials for the different purposes here, and maybe I got it here at the base, it could be a plastic obviously, and this part of it is a metal, the what you call the screw part, and then you have the one part which is an opaque material, and you have a beautifully near perfect sphere. So, design of those luminaries or what you call light fittings becomes very interesting when you have this thing here. You see here is even better. I have a even more globular, even more interesting what you call in this beautiful perfectly spherical, I mean near perfect spherical, which I can use for all my purposes here. So, I will now what you call skip and get back to the one of the points in my lecture. So, allow me to what you call start with it is not an apology, an acknowledgement that somebody has printed materials of using different materials, the same type of a job, and they have made this available to us. It is for us to read along. This particular thing is called the Tom's Guide, various materials here. Let me make it just smaller and it will be easier for me to manage. You see here the starting point is usually ABS. ABS is acryl or nitrile butadiene styrene, tough, very common, non-toxic. So, there are I mean something about a high melting point. Why is it a con and why it is not a pro? Con is because that much higher what do you call melting is required, and hence the layup and all may be smelly. And on the right column they have given a deal about how these things are, and next very commonly used thing is probably this polylactic acid acetate. These materials are easy to print and biodegradable, but degrade without our thing over time. So, like this large number of materials have been put here. Now, if you see here, same object has been printed here. Can you see? Now, you will see two are the other things. Generally, people will show you a finished product, but the finished product has got into that stage after it is being finished. When it is printed, typically if you take this, I do not know, it could be a candle holder or it could be just a decoration or anything, or it can be a 3D screensaver, something picked from the usual screensavers. If you see here, we have a multi-pointed star, and you see here at the bottom what do we have? These are all the support materials. You read it for yourself at this point. So, the interesting thing, just like the way I like to talk, it says if anybody stepped on a Lego brick, will tell you, hey, this stuff, it hurts and it is sharp with these things and all that, and it is also water and chemical resistant, and in general it is not toxic. So, even if a baby tries to chew it, there is no issue about it. Only problem is that we have a little what do you call problem in melting. Okay. Then cons, high melting point, unpleasant fume, not suitable for outdoor because it is not resistant to UV, mild degradation is there. First signs of it is the surface color fades, whatever filler is used, it starts fading, and once it fades, whatever the aesthetic effects for which we have printed it will be lost, and it is partly shielded or things like that. And then we have a problem of it looking ugly, because a lot of our life depends on identifying things by shades of color. So, when UV happens, the color changes. Compatible with which heat up to 220, such as so on and so on like that. Next one is, you see the other one,